Good afternoon, ladies and gentlemen of Algebra 2 Honors. This one here, number 12, you could rewrite this as 1/2 1 over x plus 2, and then on the outside here put plus 3. And so you're trying to graph this function here and then find its domain and range. And it says, I think it says find the asymptotes too, doesn't it? Yeah, find the asymptotes and the reference points. Yeah, so you're translating the reference points.
Oh, because I forgot to change it to the left. Tell me what you put for these. Wait, I just have we should have just said this one. And then what? Except that's the problem. That's what I don't know. I'm just knowing x-axis. Yeah. I've just been doing the x-axis. Because I don't know if I'm supposed to be like, because look, if I get this point, does that mean that the first one is negative 1? Okay, so that's what I got. And then this point, the first would be negative 3. Okay, and then I just go ahead. Left, or did you go to move the points? You went left. I went left because plus 2 means go left. Like in the actual thing. Plus 2 means left, and then negative 2 means right. Right? Yeah. Okay.
Okay. So I've heard some good discussion here. And I think just sitting where I am in this classroom, I can hear the discussion going pretty well. These girls here always have a great discussion. And these guys over here do too. But they're not as close to me. All right. Here we go. Okay. Are we going to have Peyton? We're going to have Peyton on this one.
Oh, you
No, I can't
serious?
do it, Mr. Duke.
Oh,
No, Mr. Duke, I don't know what I'm doing.
It lied.
No, I don't know what I'm doing.
Oh, no, we can do it.
All right, Connor, what do we got?
No.
Serious?
What's up, Mr. Duke? Okay, so I got my center is negative 230.
Okay. Really, I hope it's the kind of thing that if you realize that you get to the center, then it's kind of downhill from there. Like that should be almost the hardest part of it, right? Because after that, the thing should. No, it's not true.
No, it's pretty simple.
Yeah, let's work with some. But anyway, we have that. So let's be grateful for what we have, right?
I have a line at negative 2. Yeah,
Like this, Connor. Okay.
and I have one going across at 3.
So like this.
Yes, sir.
So you have y equals 3, right? Okay.
And I have my points down for you moving it. There's one at 1, 4, or negative 1, 4, my bad. And then I have, I have one at negative 3, 2. I think those are right.
So this one here, you move to the left 2 and up 3.
Yes, sir.
So let's do that. So you take this 2 left. Actually, you're taking this one, right? 2 left and up 1, 2, 3. So right here. So that's going to be negative 3 something. Then this one here, you move 2 left and up 3 to right here, which is going to be -1. Okay? And then what's our factor we stretch or compress by?
Using a half.
So is that a stretch or compression?
I can't ever remember these, I always get them mixed up.
He said stretch pressure.
Stretch pressure?
It's one of the others. Is it a compression?
Why would, yes it is. Why would it be a compression?
Because it's below 1.
Less than 1, yeah, exactly. So now we have this point right here that we translated, and then we go ahead and compress. So it goes right here, doesn't it? So that's going to be -1. What's going to be our y coordinate there? It's going to be
3.5.
3.5. So I just put 3.5, right? And then this one here, the -3, well, -3, and up here, and we're going to go ahead like this, right? So 2.5. Then we can graph this by, okay, we went right here, up. It's going to go like this, kind of like this, right? Something like that. And this one here is going to go something like that. My motor control is not very good. Okay, right like this. To the right, to the right, to the right. There, that's not so bad. Okay, what is our, so this will be the translated points. What is our domain of this thing?
It'd be, come on, let me see. X is less than 1, and then X is greater than 1. Is that right?
-2.
Oh, that's not necessary.
-2?
Yeah.
-2, okay.
Yeah.
X is greater than -2. It's supposed to be greater than right here, greater than -2. That's supposed to be greater than. Hope you can read my mind. Then you have X such that X is what? Element of all real numbers.
Shut up, I'm trying to say.
But X cannot equal -2.
I don't like these funky bracket things on that
I don't want any of this.
You don't like them,
one. If I could draw,
or you like them?
I don't.
You don't like them? Yeah, they're a little weird. If you look at them kind of like, it kind of looks like a face, doesn't it? Looks like you have a forehead, a nose, like a, doesn't it? Doesn't it a little bit?
I guess.
What about that one?
It's a different type of face.
It's,
This is more like, this one on the left is more like Fred Flintstone.
Kind of looks like Jay, you know?
Okay, then we go like this.
Oh, kissing on the mouth.
Oops.
what is numbers confusing?
Yeah. All right, Connor, what about our range, Connor? What do we
Come
got?
on, let's hear that read.
It's Y is greater than 3, and Y is less than 3.
Y is less than 3, okay. Okay, and then
What's the,
Y,
Y is such that, Y is all the numbers, and Y is, not, oh wait, exactly, not equal things,
not
yeah,
equal to
3.
3.
Finally, we have this one right here.
It'll be negative infinity,
is that done now? I think it is, right? We got everything done? Got our asymptotes, domain range? Yeah, so we can pick this up. We're going to start working on another exercise today. This will be with problem 13, which is going to be similar, but not exactly the same. You should. Is that the hardest part?
Yeah, because it's the same, well, right in like
Finding the
one,
points is hard. I don't like this part.
in one notation, except of all three.
Yeah. And what it is part of the process is, and it's really the textbook that made the requirements, right? And what it is, they're trying to train you in different ways. Are you doing that? Yeah. Yeah, that'll work. That's what that'll work, Father. It didn't really get too bad.
No, not as bad as I thought. It was only sitting water, it's okay.
Yes, sir.
I got to hand Mr. G up there.
I didn't have this, I just didn't want to make it.
He handed it to me.
Yeah, and I owe you credit too,
Oh, okay.
so I'll do it.
I handed mine to the stack.
Yeah, right here on this sheet.
Yeah, look for the messy one. That was coming. Oh, yeah.
All right, very good.
Please.
This for you, Connor. Good work. Okay, put this here. All right, if you look at your paper by now that I've handed out, you can see that this is a brand new exercise set.
Yeah, we ain't got no points.
Yeah, you don't have points, but we're going to actually use what they would have been. So essentially what we're going to do is we're still going to be able to take the same things we did over here and take the standard thing here, and we're going to transform, we're going to use these points. And the thing you have to remember about these points here is they're going to, from the center, they're going to be one to the right and one up, this other one to the left and one down.
So
that's-
it's going to be 1 and 1 and 1 negative 1?
Yeah.
Negative 1 and 1?
And it's going to help us in graphing. It's going to help us in graphing essentially what this is. And so what we have is in problems 13, 14, 15, and 16, what we have is we're given this a quotient of two linear binomials as a function. It says to rewrite the function in this form here, and we're going to rewrite all of them in this form here. We're not going to use this form here. We're going to use this form here, okay? It's just going to make things easier for us. Now, do you have a strategy for getting from this form here up to this form here?
Ben said he does.
Yep.
What is your strategy?
You write it, I don't know, like for the first one, it would be 3 is A. 3 is on the outside.
So you think 3 is A? Okay, let's do this.
Okay, you shall see.
I don't know, A would be 0.
And K would be 0.
I don't.
So you don't, what you're saying is you don't really know, so
I know what A is.
you know what A is though? You know A is 3? Okay. Let's go ahead, we'll go ahead and look at this, because one thing that you may not realize, that this connects super well with something we did not too long ago. In fact, I think it was actually this semester, one of the first things we did this semester, I think. Synthetic division?
Yes or no?
Yes.
Okay, I understand that.
Or division, synthetic division or division, yes. So you go back. So I want you to go ahead and see if you can synthetically divide that, and I'm going to talk about that in a minute,
Is
okay?
that one with the with the bracket that looks like an L,
Yeah.
and then you
Yeah.
drop down. Okay.
No, it's like, I forgot the square.
Oh, the one that's like a W?
Yeah.
Yeah.
It's like a square here.
Oh, why didn't you grab that?
As far as where we're heading in the class, I think today and tomorrow we should work through these problems 13 through 20. And then Friday, we're going to start previewing for a test. Just what you want.
Tests.
Right?
Okay. So,
Okay, so I have the equation set up.
so anyway, what I'm going to do is I'm glad you remember that. So we take this thing like this, right?
I should have done
Like many of you said. So here we put 1 out here, and we put 3, -5 here. So we bring this down and get 3, and then we multiply through and get 3, and then we add these up and get -2. And so what this is going to be our remainder, which is -2 times 1 over x minus 1. You keep that same divisor there, right? And then plus 3. Now, do you remember a little bit ago Ben was thinking that 3 was going to be our value of a? Well, it's not, is it? So it's a little tricky, isn't it? So now do we have something we can work with? Yes. And so what is our center going to be?
1/5.
So 1, 3, that's going to be our center. So we go to x equals 1. Beep, beep, beep. X equals 1. And x equals 3. Or y equals 3. Excuse me, I said x equals 3, didn't I? I'm going to say y equals 3. Okay, and so what we've done is we've taken the axes and we've shifted them up to the right 1 and up 3, haven't we? Okay. And what we can do is we can carry along with us these original reference points. Up, right 1, up 1, left 1, down 1, right here. Right? So I'm just marking those temporarily, because what else do we have to concern ourselves with? -2. So that is what? What does that -2 do? Vertical stretch. That's 1. What else? Reflect about the x-axis. But it's a revised x-axis, isn't it? So we're going to take this thing and we're going to stretch by a factor of 2 about the horizontal asymptote, and then move it right down here, right? So this thing, so this is the original point, stretched by factor of 2, reflected about the horizontal asymptote. So that's one of the points we're going to use to draw the graph. And that's 2 units from the horizontal asymptote. So we can mark another point 2 units from the vertical asymptote, and the graph of that is going to look like this. Something like that. You see what it's doing? It's approaching the asymptotes on either side. And then, for the other one, we're going to have this same thing here, stretched by a factor of 2, and then right over here. So this thing comes right over here. So now we have this point here, and then we can sketch this in too. And so that's what the graph of this is going to look like. Does that look like it should? Kind of? You can test with your calculator, right? And then finally it says state the domain and range.
Why don't you have to write 1 and 1 becomes that? And then
Yeah, now here's what happens is, as you can see, the instructions to do that aren't here. Okay, they aren't here, but that's still a good observation, because even though we didn't formally put it down, didn't we actually use that technique here by moving that over? So I think what they're doing is they're kind of scaffolding your understanding by moving you from looking at those reference points, and then when you get to 13 and beyond, you can use those to find what you have. And if you just peek ahead to problem 17, you're going to be given a graph and then work backwards from the graph to find what the equation is. So we're looking over this whole thing kind of inside out, different types of ways of looking at things, aren't we? So our domain's going to be x is greater than 1, x is less than 1, and then we have x such that x is element of all real numbers, but x cannot equal 1. And then we're going to have like this, negative infinity, comma 1, union 1, comma infinity. And then for range, I'm going to write my range over here. We have our horizontal asymptote of y equals 3. Does it ever happen to you, you get cramps in your hand when you're writing too much? Do you think I write too much?
More than us.
Sometimes, more than you, yeah, exactly. Okay, range is going to be y is less than 3, y is greater than 3. And then we have y such that y is element of all real numbers. However, y cannot equal 3. And finally, the interval notation, negative infinity, comma 3, union 3, comma infinity. And so that's going to be it, our range, our domain. Now, I want to go ahead and give you a little technique hint on number 14, because if you look at number 14, it's not the same, is it?
No.
Especially in the denominator, especially. So before, if you probably already started working on this, what you're trying to do is get 1x down here. It's just going to make your life easier. So what do I have to multiply?
2.
We have to multiply by 2, and we're going to multiply by 2 over 2. Why can I multiply by 2 over 2?
Because you're 1.
Yeah, because 2 over 2 is equivalent to 1. So when you multiply by some number over the same number, you're just kind of putting it in a different format. Yeah, the proportion, right. So here we have this 2 times x, so we get 2x plus 10 over x plus 4. And so now you can find your, do the dividing you need to and all that, right? And I will choose somebody here in another couple minutes.
Yeah, you played on this for me. I didn't. multiply, no, it'd be negative.
Right.
I like how
And well, if it's, you know,
Like the
plus
same
4,
thing.
so you plus 4 instead of minus
So this will be negative 4.
Didn't want to say.
4. It's gotta be the 0. It's 4.
Yeah, does your sharpener work?
I think it does. It's on the windowsill. I think it does work pretty well. I use it. It's working?
Yeah.
Okay, good. The problem is, it's not a real stout sharpener, so it's not the one that you can just sharpen 10 pencils in a row very
Yeah.
easily.
So it's A too?
And last year, yeah. I was thinking this. I looked at this, thinking of this. So I was looking at this, like,
No, I don't even think I have a
While people are working on the problem, I want to show the, oh, one thing, yesterday, did you see the video uploaded from this class? Did you see my face?
Yes.
Going like this? That was good. And what happens is the thumbnails are picked randomly by the computer, so by YouTube. They pick them, so I just choose them. I could custom put it in there too, but that's a lot of work. But anyway, Ben was noticing the shirt today. So there are, we would say the integral from 0 to 1
This is what I
of 8x cubed dx kinds of people in the world, those who understand calculus and those who don't. Those who understand calculus and those who don't. That's how many there are. So this is a very nerdy way of saying 2, right? So this is a very calculus nerd way of saying 2.
So the answer to that is 2.
Yeah. So there are 2 kinds of people in the world. Those who understand.
because then it wouldn't be funny.
I guess so.
What's the deal? And I got the idea from another similar type of a
I
joke.
was just in my water bottle. What is your obsession with my water?
You gotta try to sell that shirts too.
Actually, I haven't sold, is that I'll tell you what, like in YouTube channel, you can have a Teespring store if you have 10,000 subscribers. I don't have 10,000 subscribers.
Not yet.
Not yet, not yet.
I'll shout you out on my
You gotta release that rap album and then it'll hit 10,000.
The rap album will do it.
Yeah.
Want me to shout you out on my Instagram?
If it helps, man, if it could help, I could use any kind of help. And the people always go and look at the slope dude, and they'll look at the channel, and that's the first thing people notice, because that's the one that has the most views by far.
Which one?
Slope dude.
Oh, yeah.
And you've seen Slope Dude, right?
Yeah.
I don't remember.
Okay. Anyway, let's go ahead and spin this, get somebody going.
Before he takes me on his wheel spin.
So, I'm like fun effect.
I'll be this
So it'll just be,
Let's go, Jay, it's not too
Okay.
Okay, so,
You get a center first.
I did the division. Oh, do you want me to just give you the
No, you do the division. So let's do division like this.
-4 outside.
You did it like this?
Yes. And then 2, so bring down the 2, and that'd be -8, so it'd be 2. And so the new equation would be 2, and then parentheses 1 over x plus 4, close parentheses plus 2.
Okay, and so that's going to put our center where?
-4, 2.
And 4, 2, okay. So we do that, so we get -4, it's going to be something like this, is that right? -4 and 2. One thing I did when I copied these, I tried to get your grid a little bit darker than it was. I think it worked better. A little better. It didn't get it perfect like this, but okay, go ahead, Gabby. That's good so far. Good work. That is really awesome work. Good to continue your good work.
I don't know what to do after that.
So she says she doesn't know what to do with it, right?
Okay.
You basically,
you asked me.
You put in the numbers.
You
You just solved it, that's it.
Yeah, you really can, right? If you take, if you take -3 and -5, right?
Yeah.
You put the
Plug in -3. Why would that be? Because that's going to be 1 off. So if we plug in -3, for this one here, what do we get? So 2 times -3 is? -6 plus 10 is 4. So we got 4 in the numerator. In the denominator, we have -3 plus 4, which is 1. So we have 4 over 1, which is 4 right here. Is that right?
Yeah, sure.
And you notice that the 1, 1, if we move this over here, that's stretched by a factor of 2. And another thing you can do when you do this, you can bring this one over. If you rotate this thing around 180 degrees, you're going to come right to this other point, aren't you?
Right, yeah.
Yeah.
There's a negative one.
That's what I was just telling Jay.
And then you can sketch it in like this. So I'm kind of hastily doing it. But you see how this is really not such a bad thing?
Yes, it is a bad thing.
It is a bad thing.
It's
Okay, where did you get
I'm
the
getting-
-3 from?
Okay, where did you get the,
So what you do.
Yeah.
first part?
So,
do you
I
understand?
just-
You understand this?
okay, so you
Ben.
Why is he dealing with all the fraction stuff like 10?
Where did you pull that
Where did you
-3
get
from?
There's no
-3?
What do you mean -3?
You said
When you
2
said-
times -3 plus 10. Where did you get the -3 from?
I got the -3 because remember we talked about our reference points? So I'm going to have to move this one over here 4 to the left. So this one here, move 4 to the left,
And then up to,
is -3, then up 2 goes right here. Then you stretch by a factor of 2, comes right up to here.
Plus 4 is 1.
I'm still not understanding what's
okay,
in
Mr.
this.
But really, when you think about it, it helps to get some experience at it, doesn't it?
I understand.
And just by the time you get experience of that, what do? Move on to something else. That's the way it works. But anyway, that's pretty much it, isn't it? And then we have our domain. What is our domain?
The domain would be
So
x
no,
is
no.
less than -4 and x is greater than
X greater than -4. And then x such that x is
An element of all real numbers.
except x cannot equal -4. And then -infinity 4 union -4 colon infinity. And then over here range
y is less than 2 and y is greater than 2.
y is less than 2, y is greater than 2. And just checking here, yeah, that's a result of that, so it's good, okay. And then y, so it's at y, element of all real numbers, but y cannot equal 2. Oh, my pen's getting a little glitchy. Okay, then we have infinity 2, union, yeah. My hand's getting a little cramped. So anyway, that's our domain and range for that one. You know, what I want to do with 15 is that we have very little time of class left. So let's just kind of start 15. So I want somebody, I think 15 is already, yeah, so this one is kind of set up. So I want you at least to get somewhere to the center of it. So we may not finish totally 15 today.
Like trying to find the center?
Yeah, you try to find the center. What you do when you find H and K, what you get after you divide out and find what that is. Thank you, Gabby, that's really good.
Does anybody understand?
little
2
dots?
plus 3,
What did you get for like?
and then the center
No, I'm
is
G of x equals 3,
3.
1 over x minus 2 minus 4.
Okay, here we go.
That's not right.
2
Why?
negative 1.
If I'm correct.
2 negative.
Yeah, you are correct, actually, because there's
Let's go,
a...
Mark.
Marcus.
Boy, Mark.
Okay, we got Marcus here. All right, Marcus, what do you think?
You that box.
Into the center.
Do the box thing, right?
Then it would be 2 on the outside,
2.
negative 4 and 11.
So we have
2 times negative 4 would be negative 8. And then that should equal 3.
3. Okay. So g of x is equal to
It should be 3
3
plus 1 over x minus 2.
minus 2
And then minus 1.
minus 4. Okay. So what is our center going to be?
It would be 2 minus 4. I mean, 2 possibly negative 4.
So 2, 4. Okay, so we have 2 like this. So we have x equals 2, and then y equals negative 4. Okay, pretty good. That's actually really good. So what is so we have that thing right here. So what are we going to stretch by? By 3. So we come right up here, right? So we got this 1, 1 point that translate over here, and to stretch by a factor 3, what do? Move it up here. So there it is. That's our translate point, and we can use that to graph part of it like this, right? And then this other one, we can rotate around 180 degrees. We'll come right here, won't we? Or we can go to this one right here, and then we have this point over here. See, this is 3 from the horizontal asymptote, so we're also going to have 3 from this vertical asymptote, so we can just sketch this in like this. And then all we have left now is the what? Domain and range. But I'm just going to kind of leave it there, so we'll just kind of talk about that tomorrow, and a lot of good work there. Yeah, so Mark can do that tomorrow. I'm going to save this so we can come right back to where we are in all the classes.
I finally did it, it's right in the